Hello my students, how are you? I am Saiful Islam. Hope everyone is well. Today I will discuss about Wheatstone Bridge. In 1843, Professor of London King's College, Charles Wheatstone invented this bridge to determine the medium resistance of a conductor. Okay, the medium resistance of a conductor. Now you have to know what is medium resistance. Okay, according to range, resistance are three types. Okay, the three types resistance are: first one is low resistance. Okay, low resistance, when the resistance of a conductor is less than 1 ohm, that is called the low resistance, like as 0.003 ohm. It is low resistance because it is less than 1 ohm. Next, the medium resistance. Okay, when the resistance is 1 ohm to 1000 ohm, then the resistance is called medium resistance. High resistance. What is high resistance? When the resistance of a conductor is greater than 1000 ohm, then it is called high resistance. Okay, by using the Wheatstone bridge principle, we can calculate the medium resistance of any conductor. Okay, now I will show you the circuit diagram of Wheatstone bridge. Stay with me. In Wheatstone bridge, 4 resistors are connected in series. Okay, like as this resistance is P, this resistance is Q, this resistance is S, and this resistance is R. Okay, P, Q, R, S. These 4 resistors are connected in series. How they are in series? Now, if we consider this point is A, this point is B, this point is C, and this point is D. Okay, if we consider the resistance P, then this leg will be the first leg. Okay, and this leg will be the second leg. Similarly, this leg will be the first leg of resistance Q, and this leg will be the second leg of resistance Q. Again, this leg will be the first leg of the resistance S, and this leg will be the second leg of resistance S. This leg will be the first leg, and this leg will be the second leg. Okay, so we are getting the second end of P is connected the first end of Q. That's why it is series. PQ are series. Similarly, the second legs and the first leg of Q and S are connected at point C. That's why they are in series. Again, at point D, the second leg of S are connected with the first leg of R. That's why they are series. Again, at point A, the second leg of R is connected with the first leg of P. That's why RP are in series. So we can say PQ, RS, all the 4 resistors are connected in series. Okay, it is also called diamond shape closed circuit because it's look like a diamond. Okay, now a battery or a cell and a key are connected between the 2 opposite ends A and C. Okay, here low voltage battery is used. Suppose its electromotive force is E and the key is denoted by K. Okay. Now between the two opposite ends B and D, a galvanometer G is used, okay, to determine the current flow, to detect the current flow along PD. Okay, suppose the resistance of this galvanometer is G. Now, by controlling P, Q, R, S, the potential at point A, at point B, at point C, and at point D are fixed. Okay, suppose at point A the potential is VA, at point B the potential is VB, at point C the potential is VC, and at point D the potential is VD. Okay, by controlling P and Q, PQ, RS, the potential are taken as so that the potential at point A, VA, may be greater than at potential B, VB, and the potential of B greater than potential at point D, and the potential at point D is greater than at potential C. So we are getting that this circuit is designed as that the potential VA is greater than VB and VB is greater than VD, VD greater than VC. Okay, and we know current always flow from higher potential to lower potential. Okay, now the working function of this circuit, when we switch on the key, then current flows from the battery. Okay, suppose the current which is flow from the battery is I. Okay, this current is called main current. You know the current which flows from battery is called main current. Okay, now when the main current reaches at point A, then it divided into two paths. As the potential VA is greater than VB, that's why the current will flow from A to B through the resistance P. Suppose this current is I1. Another current will flow from A to D through the resistance R. Suppose this current is I2. Okay. When the current I1 reaches at point B, then it again divided into two paths. Okay, one is from B to D. As the potential VB is greater than VD, that's why it flows from B to D through the galvanometer. Okay, so we consider this current is IG. Okay, another current will flow from B to C through the resistance Q. Suppose this current is I3. Okay, now the current I2 will reach at point D. At that time the current IG will also reach at point D. So at point D the I2 and IG will meet together, and we consider the summation of I2 and IG is I4. This I4 will flow from D to C across the resistance S. Okay, so this current is I4. When the current I2 reaches at point D, then it will not divide it into two paths. It will not flow from D to B. Why? Because the potential at point D is less than the potential at point P. Okay, so at point C we are getting that I3 and I4 meets together. Okay, here I3 plus I4, and the summation of I3 and I4 will be the main current I. So the main current will flow from C and it will come back again the battery. So here we are getting that the outgoing current is I and the incoming current is also I. That is, the main current are same. So the main current follows the conservation law. There is no loss of main current here. Okay, in this way the current flows all branches of this circuit. Now, what is the equation of this breeze? Now, the equation. To get the equation, we have to use Kirchhoff's law. You know, there are two laws of Kirchhoff. First one is junction law. Now we can use the junction law at point B and at point D. So at point B, using junction law, what we get? Here at point B, I1 is incoming current and IZ is outgoing and I3 is outgoing current. So according to junction law, I1 minus IZ minus I3 equals to 0. Here IG and I3 is minus. Why? Because they are outgoing current. Okay. Again at point D, we can use the junction law. So here I2 is incoming current, IZ is also incoming current, but I4 is outgoing current. That's why here we can write I2 plus IZ minus I4 equals to 0. Okay. Next, we can use the voltage law or the loop law at A, B, D, A closed circuit. Okay, at A, B, D, A closed circuit, we can use the voltage law or the loop law. Here we consider the flow of current along the clockwise. Okay, the current is flowing along the clockwise, we consider it. So according to voltage law, here the voltage I1P, we get I1P plus, here the current is Ig and the resistance is capital G. That's why we can write Iz into G. But here I2 current is anti-clockwise. This I2 current is flowing anti-clockwise, though I1 and Iz is flowing clockwise. So the direction of I2 is opposite with I1 and Iz. That's why here we have to use minus sign. So it will be minus I2R equals to, in this closed circuit there is no battery, there is no cell, or there is no electromotive force. That's why according to junction law, here the value of E is 0. Okay. Next, at the closed circuit C, B, D, C, again we get, here we also consider the current is flowing clockwise. Okay, we also can consider anti-clockwise. If we use clockwise or anti-clockwise, both cases the result will be same. Okay, now here I am taking the current is flowing clockwise. So here I3 is clockwise, that's why it will be I3Q. Again, the I4 is anti-clockwise, it is flowing opposite with I3, that's why it will be minus I4S. Again, Iz is flowing anti-clockwise. Okay, its direction is downward, that's why it is opposite with I3, so it will be also minus IZZ. equals to 0. Okay, now the balance condition. To get the circuit as balance, what do we have to do now? Now you know that P, Q, R, S, these four resistors are a variable. Okay, now adjusting the resistance S, we can meet the potential at point B and at point D are equal. Okay, here the potential VB equals to VD. So the potential difference at the two ends B and D will be 0 because their potential are same. Okay, if the potential difference is 0, then no current will flow from B to D across the galvanometer. That's why the value Iz will be 0. Okay, this Iz is 0. In this case, the bridge will be in balance. Okay, when the Iz is 0, then the circuit becomes in balance. Okay, now taking Iz equals to 0 from this equation, we get here I1 equals to I3. Okay, here Iz is 0, that's why we get it. Okay, from this equation, as Iz is 0, we can write I2 equals to I4. Okay, next from this equation, as Iz is 0, that's why we can write I1P equals to I2R. Suppose this equation is 1. Next, from this equation, as Iz is 0, we can write I3Q equals to I4S. Let this equation is 2. Okay, now if we divide the equation 1 by equation 2, we get I1P divided by I3Q equals to I2R divided by I4S. Okay, now here I1 is equals to I3, so we can write I3P divided by I3Q equals to, here I2 is equals to I4, that's why we can write I4R equals to I4S. So from the above equation, finally we get that P by Q equals to R by S. Okay, here we get the ratio of the resistance P and Q is equals to the ratio of resistance R and S. That is, finally we got that P by Q equals to R by S. This equation is called Wheatstone bridge balance condition or null condition. Okay, finally this is the balance condition, and it is P divided by Q R equals to R by S. P divided by Q equals to R by S. Hope you have understood it. If you have any question, you can send comments in comments box. Okay, next class I will discuss about the mathematical problem by using Wheatstone bridge. Up to then, keep a smile, stay home, save lives.